So, dear students, let's get started with today's session. We are going to discuss a few more questions from the topic, that is sequences and series. Okay, so before I start with the first question for the day, let me introduce the concept related to harmonic progression. Okay, now if I am considering that P, Q, R, etc. If I say P, Q, R, etc., they are in arithmetic progression. Okay, I'm claiming that they are in arithmetic progression. Okay, then it means that 1 by P, 1 by Q, 1 by R, etc. They follow something called as harmonic progression. Okay, so this is the first thing that you have to keep in mind when you are trying to attempt questions based on harmonic progression. Okay, so I shall now tell you the reverse logic here. Okay, suppose I claim that x, y, z, etc. If I say that they are in harmonic progression, the converse I am talking about, okay, they are in harmonic progression. Okay, it automatically means that 1 by x, 1 by y, 1 by z, etc. in that pattern, they will be confirmed arithmetic progression. Okay, so today's the first two questions what we are going to consider, it is based on what I have presented here. Okay, now suppose I am considering two numbers. Okay, a comma b. Now for this a comma b, please be aware that arithmetic mean it will be a plus b divided by 2. Got it? Geometric mean it will be root of AB. This is the geometric. Now, there is something called as harmonic mean. Harmonic mean will be 2AB by A plus B. Okay, I want you guys to make a note of this. Just you consider two general numbers A comma B. Their arithmetic mean will be a plus b by 2, geometric mean will be root ab, and harmonic mean it will be 2ab by a plus b. Okay, so kindly consider this small conceptual input also. And always am will always be greater than or equal to gm. It will always be greater than or equal to hm, the harmonic mean. This will always be maintained, and this has got wide range of applications while solving problems. Okay, including maxima, minima, the values and all what we consider, it has got a heavy impact. Okay, so please make a note of this as well. Okay, now with this short introduction, let us now consider the first question for the day. Okay, so it is given if the second and the 12th terms of a harmonic progression are 1 by 8 and 1 by 58 respectively, find the 29th term. No problem. They have told you that the second term in that harmonic progression, it is equal to 1 by 8. From that, what is that I can infer, in that arithmetic progression, if I am going to consider the second term T2, that is A plus D, that is the second term, that will be equal to 8. Did you get what I just said? Don't look at it as the harmonic progression and all. Okay. We can consider that if that second term of the harmonic progression is 1 by 8, you convert that harmonic progression into arithmetic progression. So the second term of the arithmetic progression, that is a plus d, that will be equal to 8. Simple logic. Okay. In the same way, the 12th term of the harmonic progression is given as 1 by 58. So treat it as the arithmetic progression. Can I not say that the 12th term of this arithmetic progression, that is a plus 11 times d, that is equal to 58. I can write this as the second equation. Who is going to prevent me if I do like this? Got it? So now, with the help of these two equations, equation 1 and equation 2, you simply perform equation 2 minus equation 1. Just do that. You can see that here a and a will cancel off. 11d minus d, that will be 10 times d. It is equal to 58 minus 8, that is equal to 50. So that gets me d, it is equal to 5. Got it? Let this be here. Now substitute the value for d in one of the equations. You will be getting the value for a. What is a? A, it is becoming 3. You can check that 3 plus 8. Sorry, 3 plus 5. It is equal to 8. 3 plus 11 into 5, 55. 55 plus 3, it is coming as 58. It will satisfy the condition beautifully. So I got the first term and I got the common difference. Now, they are asking you to find the 29th term in that harmonic progression. Okay. So before that, let me first find out what is the 29th term when I am treating it as an arithmetic progression. What is T29? It is A plus 28 times the common difference. A, it is equal to 3 plus 28 times the common difference, it is 5. We can see that 28 into 5, that is equal to 140. Okay, plus 3. I can see that that is resulting in 143. So, treating this as an arithmetic progression, I see that the 29th term is coming as 143. Now, let us reverse it to the harmonic progression. The 29th term in that harmonic progression, what it will be? It has to be 1 by 243. Therefore, in harmonic progression, I can see that the 29th term, it got to be the 29th term, it will be 1 by 143. So for this question, this will be my answer. 1 by 143, it is going to be my answer. Okay. So that brings conclusion to our first question for the day. Let us now consider the next question. Find the harmonic mean of 5 by 4, 5 by 9, 5 by 40 and 5 by 90. Okay. So please be aware. Suppose there are 4 terms A, B, C, D. Okay. The harmonic mean of A, B, C, D. That will be nothing but 4 divided by. This is the formula. There are 4 terms A, B, C, D. 4 divided by 1 by A plus 1 by B plus 1 by C plus 1 by D. Okay. So this is what we have to consider in this particular, for solving this particular question. We have got 4 terms, right? A, B, C, D. The harmonic mean is calculated using this result 4 by 1 by A plus 1 by B plus 1 by C plus 1 by D. We will do this calculation, okay? Now, let's see what is happening here. Here, the first term, it is 5 by 4. The second term, it is 5 by 9. The third guy is 5 by 40. The fourth guy, it is 5 by 19. Okay, so 4 terms are there. So, its harmonic mean, that will be nothing but 4 divided by 1 by 5 by 4. Okay, 1 by a. Here, instead of a, we have 5 by 4. So 1 by 5 by 4, it is 4 by 5. Plus, similarly, 1 by 5 by 9. That is nothing but 9 by 5. Similarly, 1 by 5 by 14. It is 14 by 5. 1 by 5 by 19. That is 19 by 5. It comes like this. Got it? Now it's very simple. Okay. 4 divided by, we can add this 4 and 9 and 14 and 19. You can see that 9 plus 4, it is 13. 13 plus 14, that is equal to 27. Plus 19, it is equal to 46. So the total, I can say it is 4 by 46 upon 5 it will come. So what is that harmonic mean now? It will be 4 divided by 46 upon 5. I can now simplify this. You know how this is going to change? This will be 4 into 5 upon 46. Okay, 5 upon 46 it will come. And on further simplification, you can see that this is 20 upon 46. Okay, which eventually can be further simplified as 10 upon 23. Okay, so that is going to be the answer for the second question for the day. The harmonic mean of these 4 guys, it will be 10 upon 23. Okay. Now let's go ahead with the third question for the day. You are asked to find the value of 1 plus 2x plus 3x square plus 4x cube plus etc. up to infinity when x is equal to 1 by 3. Please note, this adds up to infinity, okay, when x is equal to 1 by 3. So let me do one thing. I will say that the sum, it is equal to 1 plus 2x plus 3x square plus 4x cube plus etc. Okay, so to start with, I have it like this. Now, let me do one thing. Let me multiply this with x on left hand side and right hand side. So can I not say that s times x, it is equal to x plus 2x square plus 3x cube plus etc. I didn't do much. I just multiplied this guy with x. So same thing I'm repeating on the right hand side. So this will become like x plus 2x square plus 3x square plus, okay, for, what I meant is x plus 2x square plus 3x cube plus 4x power 4 plus extra, etc. Like that it goes. Okay. Just for convenience, I just pushed this guy to right hand side. I'm going to do some calculations. That's why I wrote it like this. Okay, now just observe. If I am going to perform, okay, I'm calling this as the first equation. Okay, for that, please note, I'm calling this top one as the first equation. The niche wala one, I consider it as the second equation. Okay, so equation 1 and equation 2 I have. Suppose I am going to perform equation 1 minus equation 2. You know what will happen? You have s minus s times x. So I can take that s outside. 1 minus x I have. That is equal to, please observe closely. This 1, anyway, it will be retained as 1 plus, see this 2x minus x. What is 2x minus x? It is x plus, please observe this, we have 3x square minus 2x square. What is that? That is x square plus. Observe this. 4x cube minus 3x cube. What is that? That is equal to x cube. Can I see the pattern here? This will become x power 4. This will become x power 5. And it proceeds up to infinity because they have told you that the sequence it is going up to infinity. Got it? So s times 1 minus x is equal to 1 plus x square plus x cube plus blah blah blah. So that helps me to understand this is basically pointing to sum to infinity. I hope you all remember sum to infinity is given by a by the first term by 1 minus the common ratio. Here you see the common ratio, it is corresponding to x. So 1 into x is x into x square into x cube into x power 4, so on and so forth. So I can see that s times 1 minus x, this is sum to infinity of what is presented here, which is a by 1 minus r, 1 by 1 minus x you have. So from this, can I not see this sum? It will be 1 by 1 minus x, the whole square. What did I do here? I just took this 1 minus x to the denominator. So this will be s, it is equal to 1 by 1 minus x, the whole square. Now see this, our work is over. You are asked to take the value for x as 1 by 3, right? So first, let me calculate the value for that 1 minus 1 by 3. That is 1 minus x. Okay, 1 minus 1 by 3. You can see that that is nothing but 2 by 3. Okay, so now what is that 1 minus x the whole square, like what we calculated? What will be that? That will be nothing but 2 by 3 the whole square, that is equal to 9, 2 square 4, 4 by 9. Got it? So please be aware of this 1 by 1 minus x, that is equal to 2 by 3. But you are asked to find 1 by 1 minus x the whole square. So what is going to happen? You can see s is coming as 1 by 1 minus x is 2 by 3. 1 minus x the whole square will come as 2 by 3. The whole square it will come, and I can say this result will come as 1 by 4 by 9. And upon simplification, you can say the sum will come here as 9 upon 4. And for this question, this will be the value that you are asked to find. Find the value of this guy. That is what they have asked you. I have assumed that value of this guy, it is equal to s. Okay, so that s is nothing but 9 by 4. So the value of this guy up to infinity, it will be 9 by 4. That is the answer. Okay, there is one more question similar in line to what we just saw. I shall just quickly explain that and then take all your questions. Okay, let's go ahead with the next one. Here, find the values 1 plus 3x plus 6x square plus 10x cube plus 15x power 4, etc. It goes up to infinity. You are asked to find the value of this guy when x is equal to 3 by 4. Okay, so let me say the same logic. Okay, let me say that here s, it is equal to 1 plus, let me leave some space here, okay, 3x plus 6x square plus 10x cube plus 15x power 4 plus so on and so forth. Let me just try what is s into x. That will come here as x plus 3x square plus 6x cube plus 10x power 4 plus so on and so forth. Just see, I'm multiplying this guy with x. So x plus 3x square plus 6x cube plus 10x power 4 plus, you can extend it. Okay, 15x power 5, like that it goes. Now, like what I did earlier, just you subtract the first equation minus the second equation you do. So that will fetch you s times 1 minus x. Okay, just closely observe it, s minus sx. I'm taking that s outside, s into 1 minus x. That will be equal to 1 plus, observe it, 3x minus x. That is equal to 2x. plus, please observe, 6x square minus 3x square. You know what it is? That is equal to 3x square plus 10x cube minus 6x cube. What is that? 4x cube plus 15x power 4 minus 10x power 4. What is that? 5x power 4. If you want to write further, you can continue to write. You can see there is a pattern here. You see 1, 2, 3, 4, 5. So the next has to be 6x power 5. And it continues in that way. See the pattern there. Okay, so that is nothing but s into 1 minus x. Okay, now what I am trying to do is, I want to express it something like I want to get sum to infinity, a by 1 minus r. I want to get that progression. But here, I'm not able to get the common ratio part correctly. Okay, so I'm just trying to do that. Okay, so what I am planning to do is I will multiply this guy, what I obtained here. Just see what I obtained here. I'm going to multiply this guy with x once again and see what is going to happen. So now this will be s into x into 1 minus x. You know what I did? This guy, I'm simply going to multiply it with one more x. I'm sitting simply, right? I'm just going to multiply that guy with one more x. So then what will happen? You can see that 1 into x, this is x. 2x into x, that is 2x square. 3x square into x, that is 3x cube. 4x cube into x, that is 4x power 4 plus so on and so forth. Something interesting is coming here. See, if I'm going to subtract the first equation minus the second equation, see, if I'm just going to subtract these two, okay, you know what I'm going to get? S times 1 minus x minus s times x times 1 minus x. Okay, just observe what I am doing here. This guy minus this guy I am doing. Okay, so what is going to be the outcome? I can see that here when I perform this 1 will remain as 1 only. This will be 1 only plus. See the magic here. 2x minus x, that is equal to x plus 3x square minus 2x square. What is that? X square plus 4x cube minus 3x cube. What is that? That is nothing but x cube. Don't you see the pattern here? Plus x power 4 plus etc. You can see that all these things are going up to infinity. Okay. Intentionally, I didn't write it as up to infinity because already it is defined here up to infinity. Okay. So you can see this is what you are getting. And can you tell me what is this equal to? This is nothing but a by 1 minus r. 1 by 1 minus x it will be. Just like how we did earlier, it will come as 1 by 1 minus x. The first term is 1. The common ratio, it is x, 1 by 1 minus x. Okay, now I just want to remove all those unnecessary clutters and express it in a very, very simplified format. See, this guy, which I have highlighted with yellow color, it is equal to 1 by 1 minus x. Don't you agree with me? So here, whatever common it is there, I am just going to take it out. So I have s into 1 minus x, which I can take it out. So when I do that, this will result in 1 minus x again. Just to see, I'm taking s into 1 minus x out. So 1 minus x it will come. So s into 1 minus x into 1 minus x. This is equal to 1 by 1 minus x. See the way it is actually coming out, right? So can I not say that here the sum is nothing but 1 by 1 minus x, the whole cube it comes. Just to see, 1 minus x into 1 minus x is 1 minus x the whole square. Now bring that guy to the denominator. We have another 1 minus x waiting for it. So the sum is coming as 1 by 1 minus x, the whole cube it comes. Okay, now our work is over because they are asking you what is going to be the value of this guy s when x is equal to 3 by 4. So you know what I'm going to do? First, I will put 1 minus 3 by 4. Instead of x, I will put it as 3 by 4. You know, that is nothing but 1 by 4 you will get. That is 1 minus x. Okay. Now, what is that 1 minus 3 by 4? The whole power 3. That is nothing but 1 by 4. The whole power 3. That is equal to 1 by 64 it comes. You got the point? So now the answer is ready. What is that sum? The sum is 1 by 64. So upon simplification, can you tell me what is the value that you are going to get? Put it in the chat box, please. What is the value you are going to get? S will be nothing but 64. Here we go. We got the answer, 64. Find the value of this given expression. Okay, find the value of this given expression when x is 3 by 4. So that is what I did. So in a step-by-step manner, you see how beautifully we got it in the form 1 by 1 minus x. Okay. For various competitive examination, these types of questions do come. So the standard method, you can just use it blindly. Okay. Just you want to make sure that you are able to make it in the standard geometric progression wherein we get a solid, we can define a solid common ratio. For that only, all these struggles were made. And then it actually helped us. S is equal to 1 by 1 minus x, the whole cube it will come. Simply put x, it is equal to 3 by 4. You can say this will now turn out to become S is equal to 64. And this is my final answer for our question. I'm just writing it. Okay. So take a look at this question. You are asked to find the value of 6 plus 66 plus 666 plus etc. up to n terms. Kindly note, this is not sum to infinity scenario. It is explicitly mentioned in the question that it is sum to n terms. Got it? So if that is the case, in the previous question, if you remember, they have mentioned it as it is sum to infinity. So that is why we try to convert it into that geometric progression and then proceed. Okay, so that sum to infinity formula can be applied. But here it is adding up to n terms only. Okay, so see the method, how I am going to do it. Okay, let me say S, it is equal to 6 plus 66 plus 666 plus, you want to take one more term, it will be 6666 plus etc. up to n terms. Okay. Now, I feel like taking 6 the common factor out. Then it will be 1 plus 11 plus 111 plus 1111 plus etc. up to n terms. It comes like this. Got it? Now, still I'm not in a position to express it as a geometric progression. So you know what I am doing? I am dividing this 6 with 9 and multiplying at the same time with 9. So when I'm dividing and multiplying with the same number, the value, it will not change. It will still be 6 only. 1 plus 11 plus 111 plus 1111 plus etc. up to n terms you are considering. Now you see what I'm going to do. I'm going to take this 9 inside. Okay, I'm just going to do that. Okay, then see how the numbers they are going to change. So this will now become 6 by 9 times 9 plus 99 plus 999 plus 9999 plus etc. up to n terms. Okay. Please note, don't consider using the sum to infinity formula here. It won't work because it is given sum to n terms only. In the question itself, it is made. Okay, that clear. Now the next step, it will be 6 by 9 times. Look at this 9. That 9, I will rewrite it as 10 minus 1. That's the first term. 99, I will rewrite it as 10 square 100 minus 1 plus. The third term, 999, it is 10 power 3 minus 1 plus. The fourth term, it is 9999, which is 10 power 4 minus 1 plus etc. up to n terms. It comes like this. Okay. Now see what is happening. You can clump this 10, 10 square, 10 power 3, 10 power 4, etc. in one side. Here you can say minus 1 with the second term, minus 1 with the third term, minus 1 with the fourth term. Like that, that minus 1 will happen n number of times. Because for every term, you are getting a minus 1. Like the 10 terms are there, means n times that minus 1 will come. So now I am just writing it in a little more systematic way. 6 by 9 times 10 plus 10 square plus 10 cube plus 10 power 4 plus etc. n terms minus n it will come. Got it? This is all considered up to n terms. Now, what I am going to see here is, this is nothing but, I am going to highlight it. This is nothing but a geometric progression. You are adding it up to n terms, and from that you are subtracting this n. Okay, so I can say this can be rewritten as 6 by 9 times 10, 10 square, 10 cube, 10 power 4, etc. It is a geometric progression. Sum to n terms of a geometric progression is a into r power n minus 1 by r minus 1. It comes like this. Okay, so applying that result here the first term is 10. The common ratio also it is 10, because you can say 10 into 10 is 100, into 10 is 10 power 3, into 10 is 10 power 4. So R is also 10, A is also 10. So apply that result. You can see that here this will be 10 into 10 power n minus 1 whole divided by 10 minus 1 minus this n. See the way it is actually configuring now. Okay, now it's about simplifying this guy. What is going to happen? This is 6 by 9 times. I'm taking this 10 inside, okay? So what is going to happen? 10 into 10 power n minus 10 minus, you can see that 10 minus 1 is 9. Taking that over here, it will come as minus 9n whole divided by 9 it will come. Okay, I hope this is clear to you. 10 minus 1 is 9. Taking this 10 inside, 10 into 10 power n minus 10. 10 minus 1 is 9. Taking the LCM over here, minus 9n whole divided by 9 it will come. Okay, so this is the final step as far as the question it is concerned. This can be considered as 6 divided by 9 into 9. It is equal to 81. Entire thing you are multiplying here. It will be 10 power n plus 1. Please note, 10 into 10 power n is 10 power n plus 1. Okay. Minus 9n minus 10. This is what I am getting as my answer. We can simplify this. 6 by 81, you see. 6 by 81 is as good as cancelling this guy with 3. It will be 2 divided by 27. And it is 2 by 27. 10 power n plus 1 minus 9n minus 10. It comes like this. Okay. So the entire thing you can see here in one shot. Okay. So these are the steps involved. Just see this, and it is all sum to n terms. This way we can simplify it and get our results. Okay. I hope it is clear to everyone. Alright, students, please take a look at this question. You are asked to find the sum of 2 plus 3 plus 4 plus etc. up to n terms plus 3 plus 4 plus 5 plus etc. up to n terms plus 4 plus 5 plus 6 plus etc. up to n terms. Like that, you are considering n such instances. Okay. So for better understanding of this question, I am going to present the situation that is given here in this manner. See, it is 2 plus 3 plus 4 plus 5 plus 6 plus etc. up to n terms. Okay. Now, plus, I am considering the second lot there. That is 3 plus 4 plus 5 plus 6 plus 7 plus etc. That is also added up to n terms. Plus, I am now considering the third unit over here. The third unit, when I say it is 4 plus 5 plus 6 plus etc. up to n terms. Okay. So see this, it will be 4 plus 5 plus 6 plus 7 plus 8 plus etc. up to n terms. Okay. Now, if you want to proceed further, you can see it is going to be, see, there's a pattern here, 2, 3, 4, like that it keeps going. So you can see now it is 5 plus 6 plus 7 plus 8 plus etc. That is also added up to n terms. And this procedure itself is continuing for n times. You got the point? So if you observe closely, you can see that this 2 is coming only once in this entire scenario. 2 comes only once. Okay. Now look at this 3. This 3 is coming 2 times. Look at this 4. You can see that this 4, it is coming 3 times. See this? So 2 is coming once. 3 is coming twice. 4 is coming 3 times. Okay. Now please observe. We can see that this 5, it is coming 4 times. See this? Okay, so do you see a pattern there? 2 is coming once, 3 is coming twice, 4 is coming 3 times, 5 is coming 4 times. Like that when you are considering. So, suppose I am adding it up to n terms. Okay, this n, what I am presenting here, it will be coming n minus 1 times. How did I make that particular assumption or that particular conclusion? 2 is coming once. 3 is coming 2 times. 4 it is coming 3 times. 5 it is coming 4 times. So 6 will be coming 5 times. 7 it will be coming, 6 times. It continues in that manner. Got it? So n will be coming n minus 1 times. Got it? So this given, I should say, this series, what you see in front of you, I can rewrite it like this. S is equal to 2 is coming once, 3 is coming twice, okay, 4 is coming thrice, 5, it will be coming 4 times, like that. You are adding it up to n terms, no? This n, it will be coming n minus 1 times. You got it? So that is what the series is all. 2 into 1, 3 into 2, 4 into 3, 5 into 4, etc. n into n minus 1. Okay, so I can also see that the expression for that nth term, it is n into n minus 1. Cool? Now you are asked to find the sum of all these individual terms, right? So you can consider sigma Tn is as good as sigma n into n minus 1. You are adding all those terms, which is nothing but sigma n into n minus 1. I can put it in this way. Okay, I can just do one more step here if you want for handling the situation in an effective way. I can see that this nth term can be written as n into n square minus n. It can be considered as n square minus n. Okay, this actually helps us to simplify it in an effective way. That's why. So nth term is n square minus n. Got it? So we can see summation Tn will be summation n square minus n. Okay, now I am going to take that summation on the right hand side here, I'm going to take the summation inside the bracket. So you know what will happen? This is nothing but summation n square minus summation n. It comes like this. What is summation n square? Summation n square is sum of squares of first n natural numbers, and summation is sum of first n natural numbers. Very well, you can recall sigma n square is equal to n into n plus 1 into 2n plus 1, okay, whole divided by 6, okay, and sigma n, it will be n into n plus 1 upon 2. Okay, so you just need to substitute the sigma n square and sigma n, these expressions on this and simplify it. Let's do that quickly. So this will now become n into n plus 1 into 2n plus 1, the whole divided by 6. That 6, I would like to write it as 2 into 3. Okay, because the same 6 I am writing it as 2 into 3 minus n into n plus 1 whole divided by 2. If you are observing slightly closely here, don't you see that n into n plus 1 by 2 is here? N into n plus 1 by 2 is here also. So can I take that common factor out? So now this will become n into n plus 1 divided by 2. Okay. 2n plus 1 upon 3 minus 1 it will become. Got the point? Now it is just a matter of further simplification. N into n plus 1 upon 2 into 2n plus 1 minus 3 whole divided by 3 it comes. Got it? Again, the work is not over. This can be considered as n into n plus 1 divided by 2 into 2n plus 1 minus 3, which is nothing but 2n minus 2 whole divided by 3. If you further observe closely, there is a 2 the common factor here, which I can take it out. Then this will now become n into n plus 1 into 2 times n minus 1 whole divided by 2 into 3. Got it? Now I can see that I can cancel this 2 here, and what it remains finally is our final answer. I have n into n plus 1 into n minus 1 whole divided by 3. Okay, so this is our final answer as far as our question here given it is concerned. Okay, so I'm just presenting the entire findings in one single page here so that you can see what exactly has happened here. Find the sum of all these lots up to n terms. So on simplification, I can say it will eventually come to n into n plus 1 into n minus 1 whole divided by 3. So this is the proceedings here. Okay. So I assume that this explanation, it is clear to you. Now, let us consider the next question here, which is the final question in this lot. Take a look at the question. It is given 1 by 3 square plus 1 by 4 square plus 1 by 5 square plus 1 by 6 square, etc. up to infinity. It is equal to p. You are asked to find the value of this guy. Okay, so can I not rewrite? Observe closely. Can I not rewrite this 1 by 3 square minus 1 by 4 square plus 1 by 5 square minus 1 by 6 square plus etc. up to infinity? Can I not rewrite it as 1 by 3 square plus 1 by 4 square minus 2 by 4 square? Okay, what is this 1 by 4 square minus 2 by 4 square? This is 1 minus 2, which is equal to minus 1 by 4 square. Okay, plus 1 by 5 square, I will retain it that way. Instead of writing minus 1 by 6 square, can I write it as plus 1 by 6 square minus 2 by 6 square? You know what will happen? Just observe this only. Just observe these two only. You can see that 1 by 6 square minus 2 by 6 square is 1 minus 2 minus 1 by 6 square. That is what it is written here. So if you look at it, you have 1 by 3 square minus 1 by 4 square plus 1 by 5 square minus 1 by 6 square. The same thing only you can see it here, right? And you can say this will now become 1 by 7 square and this proceeds up to infinity. Now you know what I am going to do. Just see some terms here. You can see 1 by 3 square plus 1 by 4 square plus 1 by 5 square plus 1 by 6 square plus 1 by 7 square. I can take all those things together. But wait a minute. Don't you see whatever I have highlighted here? Okay, it is going to come up to infinity. This is nothing but the value, it is P. I'm not rewriting it. Okay, just look at what all things I have highlighted with the yellow color. 1 by 3 square plus 1 by 4 square plus 1 by 5 square plus 1 by 6 square plus 1 by 7. I can replace it with P, right? So I will just go for that P minus 2 by 4 square. Okay, what is remaining here is this 2 by 4 square, it is remaining. Okay, minus 2 by 6 square. In that pattern, when you consider, you can say it is minus 2 by 4 square minus 2 by 6 square. If it goes, it will come like minus 2 by 8 square minus 2 by 10 square, so on and so forth. Got it? Now, I want you to observe another thing, very interesting thing here. Can I not write it as P minus, I will take 2 the common factor, minus 2 the common factor out. Then this will be 1 by 4 square plus 1 by 6 square plus 1 by 8 square plus 1 by 10 square plus etc. It goes up to infinity. Okay, why all these things I am doing? Because I am given only this input, it is equal to P. So in terms of that 1 by 3 square, 1 by 4 square, 1 by 5 square, 1 by 6 square, etc., I am trying to do something. Got it? Now see this further. The game is not over. See this further. P minus 2, this 1 by, I'm going to look at this 4. 4 is 2 into 2. 6 is 2 into 3. 8 is 2 into 4. 10 is 2 into 5. Okay, so using the laws of indices and all, I can rewrite it as this is 1 by 2 square into 2 square plus 1 by 2 square into 3 square plus 1 by 2 square into 4 square plus 1 by 2 square into 5 square, etc. It goes up to infinity. Don't you agree with me? The same thing, I am writing it in another format. That's all. Now see how I am going to change it. It will be P minus 2 by, you've observed it, there is a 2 square which is common in each and every term. I am trying to take that guy out. Now see the magic. 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus 1 by 5 square plus etc. It proceeds up to infinity. Wait a minute. Don't you see something interesting here? 1 by 3 square plus 1 by 4 square plus 1 by 5 square etc. up to infinity. What is that? You can see in the question it is given. This is nothing but the value P, right? So bring that value back here. So it will now become P minus. Okay, what am I waiting for? 2 by 2 square is nothing but 1 by 2, right? 2 by 2 square is 2 by 4, which is nothing but 1 by 2 times 1 by 2 square is 1 by 4 plus this entire thing what you see here, it can be replaced it as a simple P here. We are almost done. Okay. You can see minus 1 by 2. I am now taking it inside the bracket. So what is going to happen? This will be nothing but P minus 1 by 8 minus P upon 2. It comes like this. I am taking this minus 1 by 2 inside. Okay. So what will happen? Minus 1 by 2 into 1 by 4 is minus 1 by 8. Minus 1 by 2 into P. It is minus P by 2. Now please observe. You have something like P minus P by 2. What is P minus P by 2? It is equal to P by 2. So we have it as P by 2 minus 1 by 8. This P by 2, you can convert it as 4P by 8 minus 1 by 8. And here we go, my final answer comes in front of you. This answer will be 4P minus 1 whole divided by 8. Okay, they were asking you to find, look at this, okay, 4P minus 1 upon 8. They were asking you to find what is the value of this guy. So you have to express it in terms of P only. So you can say it is 4P minus 1 upon 8, right? I hope I just wrote it correctly. 4P minus 1 upon 8. Yes. This is going to be my final answer. Please observe it here. Okay. So with this question, we have reached the conclusion point with respect to the discussions on sequences and series. I believe that all these explanations that I have shared with you, it is clear to everyone. Okay. So keep practicing more and more questions. Thank you.